Hello Pre-Calculus and welcome to 6.3. This is the last section in Chapter 6 that we're going to cover. This is polar coordinates. So how do you graph on a round graph is what we're looking at. All right, here we go. So we're going to plot points in polar. We're going to do multiple sets in polar just like we did in rectangular. We're going to convert from polar to rectangular and vice versa. And we're also going to do equations in both sets. So I hope you're ready to go. Make sure you have your calculator and make sure you know where your radian and your degree mode is. First thing you have to learn is how to read a polar graph. So a polar graph, there's a pole, which is where you start, or the center, and this part to the right is your polar axis. It's where we start and we go around in a circle from here. So on this graph, your pole is here and this is your polar axis. This is how we measure everything. We go from that line. It's like our x equals 0 line. All right, r is the radius, so how far out you are on your graph. So when we go here, the radius is where I stop. So am I 1 or 2 or 3 out from this center? The angle is the angle measurement here. So let's look at this. I have to plot 315. Well, 315, we have to change that to radian because that's what my graph is in, is 7 pi over 4. So the first thing we do is we go to 7 pi over 4, which is here. We start at our pole and we go out 3. So we go 1, 2, 3. That is this point. So this is point A, this is point A. Okay, pause and try yours. You should have went to pi over 6, which is here. You should have started at your pole and went out 2. And right there, so if this was B, this is that point. Okay, next we have to learn how to plot negative, and we'll do negative angles also. So pi over 2 is where we start. So you always start at your angle. This is start. I know it's written backwards, but that's what you do. So we start at pi over 2. We're on this graph right here. Negative means I go backwards on the same line. So instead of going positive 2 like here, we're going backwards 1, 2. That's a negative 2 pi over 2. Because here's pi over 2. Backwards means we go the other direction to get our negative. Okay, pause and try yours. So 150, first thing you had to do is do that's 5 pi over 6. So we're going to go to 5 pi over 6, which is right here. So this is our graph. But now I got to go a negative 4. So I'm going backwards on that same line. So 180 degrees, out 4. 1, 2, 3, 4. And did I get it right? I think so. And I am right here. So this is negative 4, 5 pi over 6. All right, I hope you're understanding how a polar graph works. You start with the angle and you draw the radius second. All right, now this one's a little bit evil. We have to go negative pi over 4. This is a little bit off here. Can I move this? So negative pi over 4 means I'm going down pi over 4, just like we did in our other graph. So we are in our rectangular. So we are right here, negative pi over 4. Now I have to go negative 4 from here. So this is the negative angle going this way, but then I have to go the negative direction, which is this way. So I have to count 4, 1, 2, 3, 4, and we are, negative 3. And we are right here at negative 3, negative pi over 4. We have done a negative angle 2 times is what we've done. Okay, pause and try yours. Okay, negative pi is tricky because pi is this way, which means negative pi is actually this way. All right, so this is negative pi. Now you had a graph of negative 2, which means I'm going backwards on negative pi, which puts you here. I hope you did a good job. All right, so that's how you plot on a polar coordinate. Now, to get multiple things, just like before, you can add or subtract a full circle to get back to where you were, right? The same thing is true in polar. So if I have 5 pi over 4, I can add a circle to get there. Well, if I add a circle, common denominator is 8 pi. My new point is at 9 pi over 4. So that's 5. 9 pi over 4 is the exact same spot. All right? You can also do a negative, which means instead of, okay, I'm sorry, pause and do yours. So now you're going to take pi over 4. You're going to subtract a full circle, and you're going to be at negative 7 pi over 4. All right, once you did that, you should be at 5 negative 7 pi over 4. I'm not going to make you do a double negative. I'm just hoping you get used to the positive and the negative in this direction. All right, things to know. Okay, we know that cosine is x, correct? So when we're on here, we have theta. And the cosine of theta is x over r, right? If I solve for x, then that's r cosine theta. So like right here, you're on a 90 degrees. So we know that the cosine of an angle is equal to the adjacent over the hypotenuse. Multiply by the r and you have found x. So this is a polar to rectangular conversion. The same is true with y. We also know that x squared plus y squared equals r squared, your Pythagorean theorem. Sometimes we need this. Tangent is always sine over cosine or y over x. So let's go to work. I want to convert from polar to rectangular. So this is my polar. I need to get to rectangular, which means I need to find x and y. I know x is the cosine, so it's 3 cosine of pi. I know y is the sine, so it's 3 sine of pi. Now, cosine of pi we know. We know the cosine of pi is negative 1. So x value is negative 3. Sine of pi is 0, so the y is 0. So our coordinate is negative 3, 0. Okay, let's see how you do on yours. Pause and give this guy a shot. So you should have started out. X equals negative 10 cosine of pi over 6. So remember you're in radian mode now. And y equals negative 10 sine of pi over 6. All right, we know that the cosine of pi over 6 is the square root of 3 over 2. If not, you have a chart in the back to look those up, but you should have those memorized by now. And we know the sine of pi over 6 is 1/2, right? These are just your 30 degrees. Okay, that equals negative 5 square root of 3, and this one equals 5. So my point is negative 5 square root of 3, comma, lost my negative in there, negative 5. All right, I hope you did a good job. Okay, other way, we're going to go from rectangular to polar. So now this is x and y, right? Well, to get to polar, I need r. So step 1 is do the Pythagorean theorem. So x squared plus y squared equals r squared. R squared is 4, so r is 2. Step 1. Step 2, I have to find theta. There's a couple of ways to do this. The easy one is probably using the tangent. So the tangent is just y over x. Well, you're given y and you have x. So you have the negative square root of 3 over 1, which equals the negative square root of 3. So the tangent of theta, negative square root of 3 is 5 pi over 3. We have to be a little careful here because we have to know what quadrant we're in so we know what angle we're working with. Well, if we graph this, we're going to go to 1 negative square root of 3, right? So we know we are in quadrant 4. So because we're in quadrant 4, we know the tan is negative. So be a little careful with your quadrants to help you out there. So we got the negative square root of 3, which means quadrant 4, I'm going to go down. That's 5 pi over 3. Okay, there's your polar coordinate. All right, pause and try yours. Let's see how you do. Okay, step 1 is negative 1 squared. You got to find r, plus the square root of 3 squared equals r squared. So 1 plus 3 equals r squared. 4 equals r squared. R equals 2. Has to be positive because it's a radius, right? Can't be negative. Well, it can, but not yet. So now we have to figure out our tangent. Whoops, sorry. So sec 2 is our angle, and we're going to use the tan of theta equals y over x, so the square root of 3 over negative 1. All right, we had just done that above, but just to make sure. So the tan of theta equals negative square root of 3. This time, we go negative 1 square root of 3. We're here. We are in quadrant 2, so we got to be a little careful. So quadrant is the square root of 3. Okay, I know the square root of 3 is a pi over 3. So we know we're going up here. We're going pi over 3 this direction, which puts me at pi over 3. So theta equals 5 pi over 3. Right? So that means my polar coordinate is 2, 5 pi over 3. I hope you did a good job. Oh, shoot. I am so sorry. I just did the last problem and not this one. All right, so let's go here. We know this is pi over 3, which puts us at, I apologize. So pi over 3, I'm taking out 1/3, so I'm at 2 pi over 3. So that means theta equals 2 pi over 3. My fault. So that's 2 comma 2 pi over 3 because we are in quadrant 2. That's what I get when I'm distracted, right? Okay, now we're on to equations. These are a little trick here, so be careful. We got to remember that x and y in polar, that x equals r cosine theta, and y, this is y, equals r sine theta. So all we do is replace that. We replace x with r cosine, and we replace y with r sine theta. Now we have to do this math. So r cosine theta minus 1 squared, r sine theta squared. Square this, so this is just first squared, last squared, double the middle, right? Plus r squared sine squared. Now, if we look here, we have a cosine squared and a sine squared.
Good morning, Mrs. Carter.
Sorry about that. Okay, so we subtract the 1, and now we've got a cosine squared and a sine squared. Well, we know that cosine squared plus sine squared is 1. So if we can get those together, this is helpful. So we put those together here, factor out the r squared, but now it's r squared times 1. So we have r squared. But we still have negative 2r cosine theta, which is fine. So now we got to solve these. So we're going to factor out the r. So we got r equals 0, and r minus 2 cosine theta equals 0. Solve for r. We get r equals 2 cosine theta, and r equals 0. One thing to remember is that the cosine of pi over 2, or the cosine of 90, is 0. So this guy is actually included in this answer. So if you don't write him down, that is not terrible. All right? Because it's already there. Okay, pause and try yours. So you should have had 3 times r cosine theta minus r sine theta equals 6. Yours is actually easier, even though it looks really weird. If you look here, both of these have an r in common, so we just factor it out. So now I've got 3 cosine theta minus sine theta equals 6. Well, to get r by itself, I just divide. So r is equal to 6 over 3 cosine theta minus sine theta. May not be as pretty as the other one, but it's a little bit easier. Okay, let's continue on. I hope you did well with that. I know it's very different than the example. All right, we're going to create an equation from polar to rectangular. So I'm taking a polar equation and I'm changing it to a rectangular equation. Our equation, we're going to start with some simple ones. R equals 4. So it's just a radius, it's just a circle. We know that r squared equals x squared plus y squared. So we're going to plug in our 4, 16x squared plus y squared, which is what it should be, a circle with radius 4. Makes sense. Okay, try yours. So you should have done negative 3 squared equals x squared plus y squared. So you have a circle of 9 equals x squared plus y squared. Because when you have a straight radius, that is a circle on the polar coordinate. it's out 3. Like this. That's all it is, which is the exact same thing on a rectangular coordinate. All right, not quite as easy here. We have theta equals 3 pi over 4. Now this is a line, so I should somehow turn out with a line. I know the tangent of theta is equal to y over x. It's the only place we can start. It's the only thing that has theta in it. So now we plug theta into tangent. Well, the tangent of 3 pi over 4, or 45, and we're 3 pi over 4, so we know we're 3/4 of the way over, so we're in quadrant 2, right here. We know tangent's negative, so this is -1 equals y over x. So y equals x to the -1. This is a line with a -1 slope, which is what we thought we should have called. All right, try yours. So again, the only thing you had was tangent of pi over 4 equals y over x. Well, pi over 4 is in quad 1. All right, since it's in quad 1, the tangent of 45 is 1. So this time, x equals y. You have a straight line, or a line going up 1 over 1. You're 45. All right, now let's convert the other way. So we got a little bit harder. -2 secant of theta. All right, so you got r equals -2 secant of theta. I know secant is 1 over cosine. I can multiply cosine up. Well, we know that our cosine is just x equals -2. Another line, vertical, right, at -2. So what do you think this one is? Pause and give it a shot. So you should have said r is equal to 3 over the sine of theta, multiplied by sine. So r sine theta equals 3, which means y equals 3. I have another line. This time it's horizontal. All right, this one here is not as nice because I can't get r in terms of cosine or sine. Because no matter what I do, there's something in the way, that -6. So we're going to manipulate our problem a little bit. Because if I can get to r squared, right, I know that that's x squared plus y squared. So this is helping me. R on both sides. I just distributed through. R squared is x squared plus y squared. R cosine theta is x. Looking helpful. Set this equal to 0. And now we have a circle that we have to find the center of. So we're going to complete the square. Since there's 2 x's and 1 y, I don't have to do it with the y. So plus the blank and plus the blank. This is our x values. Half the middle term. Squared, 9 on both sides. So now this guy is a perfect square. He's x plus 3 squared. Y squared equals 9. So now we have a circle. Center at -3, 0. Radius equals 3. Okay, pause and your turn. Multiplied by r. So r squared equals 10. R sine theta. So this is x squared plus y squared equals 10y. Subtract the y over, so this time we have to complete the square with the y. 0 plus our blank. This is the y value. So half of 10 squared is 25. So now we have our perfect square equals 25. So this means we have a circle with center at 0, 5, and a radius of 5. Did I do this last one right? Hopefully I put my negative in. I did. All right. I hope you did well. Good luck on your homework. Make sure you post questions if you have any.